Hello everyone, Dr. Chris Martinson here on July 23rd, 2020. We're going to be talking about Covid-19, SARS-CoV-2 is the virus that causes that. The United States having a really hard time with this virus right now for all sorts of reasons. Cases are on the rise, deaths are on the rise. And as well, we're going to be looking at the data that really cements the idea that this is very much an alien virus, not from outer space. Alien in the sense that it's unlike most other viruses we've ever seen, and probably unlike any virus we've faced in a long time, if ever, as a species, because of all the different ways it can attack the body. Come on, everybody, let's go take a look at that data right now. Yes, today's presentation is titled An Alien Virus. I'll tell you why I'm using that term and phrase. No, I don't mean extraterrestrial, but certainly alien to our bodies. So we're going to take a look at that, but first, the numbers. Here we are on July 23rd, 2020, 15.4 million confirmed coronavirus cases around the world, over 631,000 deaths right now. And new cases are still climbing. We can see here with the 7-day moving average very clearly in an upslope here across the world. And as well, we're seeing deaths starting to go upwards as well. They're sloping up here. For a while there, we were wondering, is this kind of flat? We didn't know, looks a little flattish, but no, pretty much clearly from the lows back here in May, we are now much higher. So those daily deaths are certainly concerning. And if we look in the United States more specifically, because I know I've got a large United States audience here too, we can see that cases are rising here, might have leveled off for the past week or so. And as well, deaths are also now climbing. We are now over 1,000 per day, something we haven't seen since, I guess, back in May sometime. So this is a really concerning trend, and we're seeing more and more of reasons to be concerned about this, even though we have much better treatments now. We really do. Not putting people on ventilators right away. We understand that having good oxygen support is sufficient. We are learning how to modulate the immune system because this is an immune disease as much as anything. It's kind of a weird one. We're going to go into that data today. But sadly, first we're going to talk about survival panels. I remember so many conservatives were worried about something they called death panels. I'm not political. This isn't a partisan discussion at all, but there was an idea around that there would be the regulation of medical care for economic purposes once upon a time, and those were called death panels who would make the decision who lives, who dies. Today, what do we call them? Let's call them survival panels. Here, our backs are to the wall, says a Texas official. Texas hospital to turn away COVID-19 patients with poor survival chances. This came out yesterday, today again being July 23rd, 2020. A Texas hospital has formed an ethics committee to screen all COVID-19 patients for survival potential and send home those with low survival chances. Rio Grande City, Texas-based Starr County Memorial Hospital implemented an ethics committee and a triage committee to review incoming COVID-19 patients. Starr County Health Authority Jose Vasquez, doctor here, said during a July 21st video conference call, the committees will determine what type of treatment patients will likely require and whether they are likely to survive. Those deemed too fragile, sick, or elderly will be advised to go home. Patients with low recovery chances will be better cared for at home with loved ones rather than dying at a hospital potentially thousands of miles away. Here, I guess. There's nowhere to put these patients. The whole state of Texas and neighboring states have no ICU beds to spare for us, Dr. Vasquez said. It still says there are over 1,000 ICU beds open across the state. So, I don't know. Looks like there's still some capacity in here, but not in this particular hospital down here. Starr County Judge Eloy Vera said, our backs are to the wall. So that's what happens when you have a weak social distancing and a weak wear your mask policy. This is the kind of stuff that crops up as a result of that. However, we're also seeing somewhat of an effort, and we're going to go into this one a little bit pretty carefully, I guess. A New York Times article just came out very recently, yesterday, and it says, can you get COVID again? It's very unlikely, experts say. So this is running directly counter to things that we've been drawing out from case studies and reports and things like that where people seem to be getting it again. Reports of reinfection instead may be cases of drawn-out illness. A decline in antibodies is normal after a few weeks, and people are protected from the coronavirus in other ways. So all very hopeful sounding there. Let's go into the article, reading from it. Quote, "The anecdotes are alarming. A woman in L.A. seemed to recover from COVID-19, but weeks later took a turn for the worse and tested positive again. A New Jersey doctor claims several patients healed from one bout only to become reinfected with the coronavirus, and another doctor said a second round of illness was a reality for some people and was much more severe." So we've tracked a few cases that actually mirror that pretty closely. So that's what the doctor's seeing. We're seeing that in some of the anecdotes too. We still don't have really great data on what's happening here, but the anecdotes are piling up. These recent accounts tap into people's deepest anxieties that they are destined to succumb to COVID over and over, feeling progressively sicker, and will never emerge from this nightmarish pandemic. And these stories fuel fears that we won't be able to reach herd immunity, the ultimate destination where the virus can no longer find enough victims to pose a deadly threat. But the anecdotes are just that, stories without evidence of reinfections, according to nearly a dozen experts who study viruses. I haven't heard of a case where it's been truly unambiguously demonstrated, said Mark Lipsitch, an epidemiologist at Harvard's School of Public Health. And that's interesting because I don't know of a case where it's been truly unambiguously demonstrated, but we do have people who tested negative, tested positive, then had long stretches of testing negative, and then tested positive again. Now, listen, the tests have false positives, they have false negatives, they have all kinds of things. So it's true. I guess if you wanted to say unambiguously, you know what? In science, it's always a little bit ambiguous. So what are you going to do? All right, so continuing on with this article, it says, other experts are even more reassuring, and everybody's looking for some reassurance here at this point. I get that. While little is definitively known about the coronavirus just 7 months into the pandemic, the new virus is behaving like most others, they said, lending credence to the belief that herd immunity can be achieved with a vaccine. Behaving like most others. What do you mean most others? You mean like HIV? Do you mean like rhinoviruses? Do you mean like the flu? Do you mean like other coronaviruses? This is not, I don't believe it's behaving like most others. And I'm going to go into that data next. This is all a setup for reviewing, fairly extensively reviewing what we do know about, at least what we do know so far about coronavirus. All right. It may be possible for the coronavirus to strike the same person twice, but it's highly unlikely that it would do so in such a short window or to make people sicker the second time, they said. What's more likely is that some people have a drawn-out course of infection, with the virus taking a slow toll weeks to months after their initial exposure. I'm not sure that's totally reassuring, though. When you talk about other experts are even more reassuring. Oh, no, it's entirely possible maybe you're just being infected with this thing for months. It's not a reinfection. Don't worry. I don't find that terribly reassuring, to be honest. And that also is not like behaving like most other viruses. That's behaving like maybe a very rare few viruses that have such a long, protracted sort of a battle with their hosts. People infected with the coronavirus typically produce immune molecules called antibodies. Several teams have recently reported that the levels of these antibodies decline in 2 to 3 months. It's true, causing some consternation. But a drop in antibodies is perfectly normal after an acute infection subsides, said Dr. Mina, an immunologist at Harvard University. Yep, that's pretty much true. All right, and Dr. Mina took a victory lap here on Twitter today and said, this is one of the best reports about immunity, possibly because he's featured in it, so I get that. It doesn't sensationalize anything and gets insights from leading immunologists, all pointing at the same. Immunity to COVID is textbook. We should anticipate herd immunity can be achieved. So I want to take exception with that textbook thing. Later, Dr. Michael Mina clarified that, and he said I was referring to achieving herd immunity through vaccination someday. This is not an alien virus. How it grows inside of us, how humans respond to it, and how it transmits have all been almost as textbook as it comes. Thus, I believe immunity can be achieved. And I responded, didn't hear anything back. I said, you mean like how we've already achieved herd immunity against all the other common cold viruses, those at least caused by coronaviruses? Oh, wait, that's not the case. So what you're actually arguing for is that this coronavirus is not going to be textbook, and this time is going to be different. Got it. Because that's essentially what's being argued for here. But I do want to talk about this idea. This is not an alien virus. Well, let's talk about that for a bit. I'm going to make the case here for SARS-CoV-2 being alien in quotes here because I say as in being so novel. We don't have a good natural analog to compare it to. It might not be alien. We don't really have anything else to contrast it against at this point in time. So let's just review here. SARS-CoV-2, it does two major things which really causes damage inside the human body. First, hypercoagulability. That is, it's a clotting disorder. That is, people get, in this case, you're seeing a thrombus being formed down here in the blood vessel right here. And this is a little blood clot. This would be a microthrombi, a little microclot. And it's because it's just a few red blood cells here that you can actually see. And these white things binding it all together would be the fibrin and all that. So this is a clot forming. So it's hypercoagulability. People are showing up with microthrombi, clots in all the peripheral organs. It may explain the confusion, the dizziness. People are being starved for oxygen because possibly the blood flow is being blocked. It could account for a lot of the organ damage. So if it just did that, we'd say, wow, this virus is a real beast and it's going to take a while to figure out how to tame it. But it doesn't just do that. It also dysregulates the immune system. And the immune system, as you can see here plainly, is pretty complicated. So lots and lots of different things. You got killer cells, you got Th2, Th1 cells, you've got the CD4, the CD8 cells, you got basophils, the eosinophils, natural killer cells, macrophages, awesome things, love the macrophages, monocytes, mast cells, memory B cells, antibodies from the B cells, on and on. Very, very complicated thing. And it gets dysregulated by SARS-CoV-2. So the clotting disorder could have many different causes. One of the possible causes here, so we can just see SARS-CoV-2 comes in and creates an immune response to the cytokine storm. The cytokine storm itself may dysregulate the clotting function. It may be that it's hitting directly the endothelial cells that line the blood vessels, damaging them. Once those are damaged, of course, that kicks off a whole clotting cascade. That's the endothelial dysfunction and injury. And once we get all these little clots, you get all these multi-organ failure syndromes that we're seeing as a consequence of SARS-CoV-2 and its disease, COVID-19. As well, this VWS is the von Willebrand factor, the thrombin, fibrin, tissue factor, all these cascades can lead to coagulation disorders. All right. And when we look at this a little bit more, it's interesting too. There's another theory out there that I kind of like, which says it is possible that red blood cells are amplifying the COVID-19 pathology. And we talked about red blood cells before. And by the way, we have this curious thing, which we know that some blood types, A versus O, more susceptible, seemingly, to COVID-19, the disease. All right. What could it be doing with red blood cells, though? Check this out. Although not directly proven, red blood cells could be involved in COVID-19 as well. They do express both sialic acid, which is another way that SARS-CoV-2 can bind and possibly enter cells, and CD147 receptors, but not ACE2. Red blood cells do not have a nucleus or genetic material and thus are unable to support virus replication. At the same time, red blood cells have nearly no MHC or major histocompatibility complex proteins that alert immune cells. So these MHC proteins are how a cell that's been infected would alert the immune system that's outside of it. Hey, a little help over here. I might be infected. And then the immune system will come and clear that cell out. Hence, red blood cell infections are often fatal as they go undetected by the body's immune system. Despite this, viruses attaching to red blood cells would attract antibodies, contributing to antibody clumping. So the theory here is the viruses are still attaching to the red blood cells because they're still binding to either sialic acid and or the CD147 receptors. Once bound onto there, your body is still making antibodies against the viruses. Those antibodies find the virus on the outside of the red blood cell, and they attach right on. Once those antibodies have attached, now you can start to get clumping of the cells together, and this would initiate a cascade of inflammatory reactions that culminate in blood clotting. Rowe proposed in his paper high COVID-19 virus replication rates, the creation of antigen, antibody immune complexes, and indirect hemagglutination resulting in thrombosis. Hemagglutination, blood glutenating, coagulating, right? All right. So yeah, kind of a mouthful on that title, but just says, hey, listen, if you have a lot of these viruses replicating, you get these antigen, in this case, the virus blobbed up with all these antibodies, and it makes a big pile up, and that results in a clot. Okay, so that's at least what we're seeing on that side of things. And as well, all the autopsies. Here's just a couple of things. German COVID autopsy data shows thromboembolism, heavy lungs. And this was kind of cool down here from more autopsies we see here in patients who died from COVID-19 associated or influenza associated respiratory failure. The histologic pattern, as looking at the tissues, in the peripheral lung was diffuse alveolar damage with perivascular, it means around the vasculature, T-cell infiltration. The lungs, thanks Microsoft 365. The lungs from patients with COVID-19 also showed distinctive vascular features consisting of severe endothelial injury associated with the presence of intracellular virus and disrupted cell membranes. So that's a big mouthful, but it's a really important idea here, which is they saw these distinctive features that looked like the endothelial cells themselves had lots of cell virus particles inside of them, and that disrupted the cell membranes, and that caused the damage. So once the endothelial cells are damaged, these things get damaged. That, of course, initiates a whole clotting cascade that can happen as a consequence of that. All right. Continuing on here, histologic analysis of pulmonary vessels in patients with COVID-19 showed widespread thrombosis with microangiopathy. So lots of little clots, and the microvasculature they're pathologic. There's just tons of damage happening here. Alveolar capillary microthrombi were 9 times as prevalent in patients with COVID-19 as in patients with influenza. So not the flu creates microthrombi. The flu doesn't do that. And as well, kind of interesting, I hadn't heard this before, in lungs from patients with COVID-19, the amount of new vessel growth, so it turns out was 2.7 times as high as that from influenza. So the vessels are damaged, your body's trying to heal that, trying to regrow vessels. Fortunately, when the patients died, they were able to detect that and see that. So part 1, SARS-CoV-2, it's a hypercoagulability clotting disorder, does lots of damage. And then it's also, of course, it dysregulates the immune system. So we all know, and we're all familiar with the idea that SARS-2 binds to ACE2. ACE2 is the angiotensin converting enzyme 2 right here. And angiotensin is a polypeptide that is a hormone, and it regulates a lot of things. So angiotensin converting enzyme takes angiotensin 1, converts it into angiotensin 2, and then this thing is rummaging around doing stuff, and it needs to be broken down by this ACE2 receptor right here, but it's thought that this ACE2 receptor is either occupied by this big virus particle, or they're taken away because so many virus particles have bound and they've been internalized as part of the process by which SARS-CoV-2 replicates itself. Well, if you don't break down this angiotensin 2, what happens is it goes down into this other pathway, which leads to lung injury, inflammation, leaky vessels, things like that. And if you can break down angiotensin 2, that helps control the blood pressure and it blocks organ damage. So by disrupting this pathway here, making a big mess out of all this, it blocks this and it promotes more of this over here. Okay, so that's one way that we know for sure SARS-CoV-2 messes things up and dysregulates your systems a little bit, but here's dysregulating the lungs. And we also know that SARS-CoV-2, in making the case that it's a little alien, remember SARS-CoV-2 is the actual thing we're facing. There was this bat RATG13, which was a sequence of a virus that the bat lady out of the Wuhan Institute of Virology released to the world and said, oh, yeah, hey, look at this thing we found. Released that on January 20th of 2020. Kind of late in the game, particularly for something that has 96% homology similarity to SARS-CoV-2. Kind of an interesting thing to just sort of find in your database. and release out into the world. But at any rate, that's what happened. And these people went ahead and studied what how these two might compare, and discovered something pretty interesting. They say we biochemically characterize their relative stabilities and affinities for the SARS-CoV-2 receptor ACE2. And although the overall structures of human and bat virus S proteins, that's the spike proteins, are similar, very similar, there are key differences in their properties, including a more stable pre-cleavage form of human S, the human spike protein, and about 1,000-fold tighter binding affinity of SARS-CoV-2 to the human receptor. All right, 1,000-fold. So as close as rat TG13 might be or might not be, there's some idea I have in my head that it's actually it's just somebody just punched that sequence into a database. I really believe that the Nerd Has Power blog has sort of really laid that to rest for me, and for a lot of complex reasons. But at any rate, SARS-CoV-2 binds much, much, much more tightly to ACE2 than any other virus that we know about for sure, and even this one from a theoretical standpoint. And it's just bizarre that SARS-CoV-2 would have the highest affinity for human cells compared to any other species. So that's another thing that sort of says this is maybe not entirely natural, and we're going to make the case here for this thing being alien on that basis. All right. And we also know that SARS-2 binds and enters via the CD147 receptor. Their paper I originally based this on was retracted because they got some criticism that they used cell lines, not actual T cells from humans. But we know from the cell lines that have this CD147 receptor that SARS-2 binds and actually enters through that. Why is that important? Well, because the CD147 receptor is found all over white blood cells, your immune cells, right? And it controls a lot of different things. So CD147 influences angiogenesis here, which is the formation of new blood vessels through this growth factor. It's influencing the IL-6, which we know is a really important part of the inflammation pathway for COVID-19. It's influencing cyclophilin, which has a lot to do with cell proliferation, and on and on and on. So all these cell cycle regulation pieces, it's a really important thing. And by the way, you find it all over white blood cells. So check this out. Now we know that from work led by Catherine Blish at Stanford, compared single-cell RNA sequencing data of peripheral blood mononuclear cells, white blood cells, from 7 hospitalized patients with COVID-19 and 6 healthy controls. So not a huge study, but here it is. As reported in Nature Medicine, the authors find several innate immune subsets depleted in patients with COVID-19. So innate, remember, you've got 2 big branches of your immune system, the innate immune system. They found some subsets of that were completely depleted in patients with COVID-19. What happened to these white blood cells, these innate portions of your immune system? These T cells and plasmacytoid dendritic cells, DCs, were depleted in all patients with COVID-19, while conventional DCs and natural killer cells were significantly reduced in only 4 patients with ARDS. So whatever's happening, the really important cells in your innate immune system are just crushed by COVID. Away they go. Well, maybe they have the CD147 on the surface. Maybe the virus is actually directly harming the immune cells themselves the same way it damages the endothelial cells. It enters, it replicates, and ends up harming or destroying those cells, dysregulating them for sure. And as mentioned, CD147, boy, geez, just a ton of things that it can influence, and all these other different things that can happen on here: neutrophil infiltration and adhesion, migration of cells, homotypic cell aggregation, cytoskeletal architecture, adhesion, migration, signal transduction, all this stuff. It's really impacting a lot of things. So again, just like with the case where we see that SARS-CoV-2 comes in, and because it's binding with ACE2, it messes up all this other stuff over here, right? It messes up this whole entire angiotensin pathway, right? Well, similarly, we would make the same argument that potentially what's happening here is because it's binding to CD147, it's messing up all of these things too. All right, that's a possibility. How about this? SARS-CoV-2 also binds cell adhesion molecules, and so cell adhesion molecules is a CAM, two particular CAMs, cell adhesion molecules that are extensively exploited by various viruses for cell entry, are the C-type lectin domain family 4 member M, so these things right here, including this one here, CD209, L and sign right there, and dendritic specific, cell specific ICAM3, and blah, 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 blah. It has been shown that SARS-CoV, this is classic SARS, SARS-CoV-1, can bind to CD209 and CD209L, and CD209L knockout mice, where they breed mice who lose the gene for this thing, were significantly less susceptible to SARS infection. So classic SARS, this was actually, as much as it binds ACE2, turns out that if you could block binding to this receptor down here, then you could actually really confer a big survival health benefit to these mice. And check this out. A recent study demonstrated that CD209L is highly expressed in the lung and kidney epithelial and endothelial cells and mediates SARS-CoV-2 entry and infection. Oh, so now we see it here in the lung, right? And we see it in kidney epithelial and endothelial cells, and it's mediating entry and infection into these places, the lung and the kidney. So now that's starting to make sense. So, okay, what do we got? It binds to ACE2, it binds to CD147, it binds to these cell adhesion molecules. What else can it do? Hopefully that's all. Not yet. Let's go start here with it. It also binds and enters another receptor called neuropilin-1. Two studies, one led by Michael Simmons of Technical University Munich and the other by Peter Cullen and Yohai Yamauchi at the University of Bristol, suggest that neuropilin-1, NRP1, facilitates SARS-CoV-2 infection of host cells. Both teams identified a C-terminal motif in the spike protein S1 domain, generated by processing of its polybasic furin-type cleavage site. Ooh, there's that thing. 10 points for using polybasic furin cleavage site, because that's really avoided pretty heavily in most articles, weirdly enough. A neuropilin binding motif, and found that anti-NRP1 monoclonal antibodies reduced SARS-CoV-2 infection of NRP1 expressing cells in vitro. So they block this NRP1. They have an antibody against the NRP1 site. They block that, and guess what? It protects and reduces infection of NRP1 expressing cells. So that's pretty good evidence right there. Check this out, though. Simmons and collaborators further show evidence of SARS-CoV-2 infection of NRP1 expressing cells in the olfactory epithelium and olfactory bulb in 5 out of 6 deceased patients who suffered from COVID-19. Olfactory bulb. This means we now, people have this condition called anosmia. They lose the sense of smell. Well, here's an explanation for that. It's because SARS-CoV-2 is directly binding and entering the epithelial cells in olfactory epithelium via this NRP1 receptor. And as it does that, it probably comes on in, damages those cells, and they die, and next thing you know, you've lost your sense of smell. And so that explains how that, let's look at this neuropilin-1 real quickly. It is a transmembrane protein. So this is the membrane of a cell. Let's call it one of the olfactory epithelial cells. And it has a cytoplasmic domain. This is inside the cell. All of this is hanging around outside the cell. Somewhere on here, it's thought that SARS-CoV-2 would bind onto one of these things, either into this red region up here, maybe into this yellow region. I don't know. I don't have that data yet. But at any rate, that's what we're seeing in that data. So, okay, so what do we have now? This totally natural virus comes along, and not only does it have a receptor that it really prefers, the ACE2 receptor, not only is it 1,000 times more tightly bound to that receptor than even as close as natural analog, way more than a classic SARS, and then it's also binding onto receptors that can get it directly into white blood cells, your immune cells themselves, mucking up that whole system. Not only is it getting in through, that would be the CD147. Not only is it coming in through the cell adhesion molecules, but it's also coming in through neuropilin-1. So, geez, that's a lot of keys that this burglar has to break into your house with. It's just astonishing. He's got a ton of different key sets. He can get in through your basement door, your front door, your side door, and that window you thought was secured. It's crazy. As well, when I was doing this research, something kind of interesting popped out, and I just wanted to talk about a possible role for zinc here. So check this out. This popped up. Here's the link for the thing I found it in. It turns out that the spike binding motif here on your ACE2 receptor is the same place where we find the zinc binding motif. The zinc binding is right here. Here's the zinc molecule right there. Let me see if I can do this. Zinc molecules right there. All right, and so here's the idea. Maybe if you are zinc deficient and your ACE2 receptor doesn't have zinc in it, maybe that creates a change in the overall shape of this particular molecule right here. And here's the thinking behind that. Enveloped viruses such as SARS-CoV-2 access host cells by membrane fusion through either the plasma membrane or an endosomal membrane. We haven't talked about that pathway yet, but that's what happens when that gets taken inside the cell. Activation of SARS-CoV-2 spike protein through proteolytic cleavage is required for host cell entry. So thank God it has the polybasic furin cleavage site, because otherwise it wouldn't enter very well at all. Therefore, an understanding of the envelope protein activation by proteolytic cleavage is central to gaining insights to viral pathogenesis and development of potential therapeutics. The receptor binding domain of SARS-CoV-2 spike protein presents the most critical feature of this protein, which is located at the C-terminus of the S1, that's the spike protein subunit, and binds to ACE2 with high affinity. Not just high, but ridiculously high. Not just ridiculously high, but higher to humans than to any other species. A little alien, just saying. Mechanistically, it is proposed that the binding of spike protein with ACE2 induces some form of conformational changes, predisposing the spike protein to activation for membrane fusion. Once activated, a fusion peptide inserts into a target cell host membrane, and blah, it's poorly understood what happens next. Okay. Finally, the N and C terminal repeats within the S2 subunit undergo conformational changes, forming a necessary structure to enter. So, what happens is this is the ACE2 receptor here, and the spike protein has to come in, and it has to find a way to bind into this, and this overall conformation, every little fold and wiggle, really important. Well, maybe with zinc in there, it's folded one way. Maybe with zinc out of there, it's folded a slightly different way. Maybe that has something to do with this, but it's just interesting to me that the zinc binding motif for this ACE2 receptor and the spike binding motif for the S1 subunit of SARS-2, it's the same spot. They're kind of headed directed at the same spot. So take your zinc. All right, I might have one more explanation here for understanding something called the long haulers. And these are people who get COVID and they have it for 10, 20, 30, 40, 50, 60, 70, 80, 90 days now. We have people who've been sick for 90 days. They're called the long haulers. And this is kind of interesting. This person, I found this over on Reddit. They are saying here, third week of March, I had every symptom there was, and even one that was not known yet, pink eye. I was tested the first 18 hours of my fever, but my test came back negative, which happens. I was still diagnosed with COVID by 3 doctors. I started to feel better about 3 weeks. Fever finally went away. The next week, got a sore throat, was achy again. My fever came back. I was also really tired. My family physician did a whole slew of tests, a throat culture, etc., and found out that according to my antibody profile, Epstein-Barr virus was reactivated. It was not a new case of mono, but the virus reactivated or activated, they said here, due to my illness and stress on my immune system. It's been 3 months. And I believe they were meant to say, don't have my energy back. Completed listings are good, but I still have the occasional down days. So that was anecdote of one. Here's another one. Hey, long haulers, my friend and I, 30 and 65, were each separately infected. She had a 6-week stint. I had it for nearly 3 months. We each suspected that we had an Epstein-Barr virus, one of the viruses that causes mono. relapsed during our COVID illness. I asked to be tested for EBV, Epstein-Barr virus, and sure enough, tested positive for an active infection. She also tested positive. If you've been at it for a while, I believe it's worthwhile to see if you're dealing with a co-infection. While there's obviously no cure for viruses, it can help your doctor guide your treatment more effectively. In our instance, we both started antivirals for EBV and additional supportive care, and this unburdened our immune systems, allowed us to effectively clear COVID. Just my 2 cents. Yeah, absolutely. That makes a lot of sense. So your immune system gets attacked or stressed or overstressed by SARS-CoV-2. And because of that, any other viruses that are hanging around that are latent, like the Epstein-Barr virus, which you don't really fully clear for many people. You have it, you get mono, you're sick for a while, you get over it. But that means you've kind of fought the virus to a standstill and it's hiding out somewhere. Well, your immune system gets challenged, over-challenged, compromised by SARS-CoV-2, and it creates a condition where Epstein-Barr now has the upper hand and it can come back out. And so this may explain for a lot of long haulers what's happening. I highly recommend, if you are a long hauler, get out there, get the EBV test. There are antivirals you can be taking. Just because you cleared out SARS-CoV-2 and that's not in your system, it could be that you now have another virus that's come forward again. Particularly people as well. I'm going to start searching around for cytomegalovirus, CMV. I bet that's something that could come back as well. So these are all things where we would want to understand how the immune system's compromised, and that because of that, other things can come forward and emerge or re-emerge, as in the case, I believe, for these two long haulers here talking about Epstein-Barr virus. All right, bad Auntie. I just really want to reinforce the idea that you can't let your guard down. This is just a tragic case here, I think. It's just people failing to take this seriously is starting to tear families apart. This is an example of how that works out. My aunt spent time with someone who tested positive 10 days ago. She's been sick, but has been playing it off as some of her chronic health problems. I got sick a few days ago, was really confused how I could have gotten it since I haven't left the house in months. With the symptoms building for 3 days, I finally went to get a test. Haven't gotten my results yet, but my aunt finally fessed up to her exposure to COVID-19. Now she's in the hospital, just tested positive herself. I never thought she would hide something like that from us. What the fuck? We would have been so much more careful if we knew. She sneezes in the living room without covering her face at all. I'm so angry, I don't know what to do with myself. Yeah, these sorts of things are starting to pop up more and more. So absolutely take care, everybody. And I won't be around anybody who's displaying any sort of symptoms, because maybe they're like bad Auntie here, or maybe they're just unaware of what they actually have. All right, conclusions for today. U.S. cases, worldwide cases too, and deaths all on the upswing here. SARS-CoV-2, though, I gotta stress this, it's truly novel. It's just not to be trifled with. We're really only beginning to learn about its effects down here. That's it. We don't know all the things it does. We may find out it has 6 other sets of keys we didn't know about. This thing is very, 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 very unusual if it's a natural virus. I don't think it is. I think this was a gain-of-function research escapee from the WIV, and whether that's true or not, it's not totally relevant, except you have to understand that if this thing isn't natural, it means it was bestowed with some superpowers that it wouldn't have normally had coming out of nature, and that's why we got to take it seriously. We're learning more and more. Most people aren't even affected by it, really. Most people, it's not even like a bad case of the flu, but for too many people, it's a terrible case of the flu. For even too large of a proportion of those people, it's an extended battle that goes 30, 60, 90 days, maybe because things like Epstein-Barr virus are coming out. Unfortunately, this whole idea of getting to herd immunity, I don't really support that yet for this because of the data I presented 2 days ago on Tuesday, on the 21st of July, where we talked about how for other coronaviruses, your immune system, for whatever reason, doesn't take them seriously, fights off the coronavirus, drops the antibodies, seems to lose whatever other protective effects may come through T cells, and then you can get cold viruses over and over again. Maybe we'll develop a vaccine that finds a way to short-circuit that. Maybe you have to get reboostered all the time. Don't know. Maybe we'll finally come up with an effective vaccine for a coronavirus. Maybe. So we'll have to see. But for now, we're just going to have to wait and see. Otherwise, all the upsurge in cases and all the tragedy going on with those survival panels, at least in that case of that hospital in Texas, we're seeing rationing of care as well in other really hard-hit places in across the world, in India and places like that. Listen, through it all, I realize I've said this over and over again, but it just didn't have to be this way. It really didn't. There's a way to be smart about this. It's not that hard. You know, if you think back to everything I said about how the gold standard pandemic approach, step 1, halt the inbound infections. Step 2, have everybody wear a mask. That's it. You know, and other steps too. Sure, it helps to disinfect surfaces and all of that. But if people aren't spreading virus particles, that's a great first step, whether they're getting on a plane and spreading it to different countries or whether they're spreading it around your community because they're not wearing a mask and they're sneezing. Maybe like bad Auntie here, and they're sneezing out into your living room. That's just awful. So please take care of yourself. Remember, you can get a t-shirt. You can join the movement, the resilience movement. That's what I think we're all going to need as we come into this next period of time. Remember, the balancing act is all about stopping the spread of COVID or SARS-CoV-2, keeping our hospitals from being overwhelmed, but also making sure that the economy can continue to function. That last part, really a lot of concerns that the powers that be in the United States have spent too much time worrying about how to prevent the richest of the rich from experiencing any losses and far too little time about what's really going on down at Main Street, too disconnected, too much in their own bubbles to really understand what's happening. So that's why seeing all these pictures of all these people here who represent Main Street doing the things that they're doing to become resilient is really heartwarming and necessary for this. So remember, still a little bit of time to plant a garden, although we're coming up sort of towards the end of the season up here in New England to really get much more going. You people down in the South, much luckier. You have a much longer growing season. And of course, your immune system is a very complicated terrain. Make sure it has all the nutrients, macro and micro, that it needs. Quercetin, zinc, D3, very important as well. If you do get sick or feel like you're starting to get sick, these things here, take them. All right. That's it for today. Remember to resubscribe here over at Twitter, anywhere you think you might have been unsubscribed. Just check. It happens all the time. And otherwise, if you are subscribed, thank you very much. Please remember to hit like if you liked this, if you got something from this, if you found this educational. The least you could do is to just take that mouse, move it an inch, and click the little thumbs up button there. Because if you do that, then the Google and YouTube algorithms know to share this with other people like you who might enjoy this and learn something from it. So with that, I am Dr. Chris Martinson. I will see you next time. Thank you very much for listening, and we'll be back next week.
Hi, folks. This is Adam Taggart, Chris's co-founder at Peak Prosperity. To get your own Resilient shirt, simply go to peakprosperity.com/shirts. Each shirt is made of 100% organic cotton and produced in the USA. And when your shirt arrives, please send us a photo of you wearing it if you feel comfortable doing so. We'll add you to our wall of proud Peak Prosperity members who are showing the world that resilience is the way to a better future. Thanks for watching.